Assalamu alaikum dear viewers, welcome back to my YouTube channel. I hope you are doing well. Today we will solve question number 12 and 13 of exercise 3.1. Question number 10 and 11 has been solved in the last lecture. If you have not seen my last lecture, the link of that video is given in the description of this lecture. You can visit and watch that video first so that every concept of yours is clear. Now let's start our question number 12. Question number 12 is show that the line segments joining the midpoints of the diagonals and the midpoints of any two opposite sides of a quadrilateral consecutively form a parallelogram. So here I have considered a quadrilateral A, B, C and D with position vectors small a, small b, small c and small d respectively. And the two midpoints of its quadrilaterals are G and H. G is the midpoint of this diagonal and H is the midpoint of this diagonal. And the midpoint of remaining two sides are uh, the midpoint of CD is F and the midpoint of AB is E. So let's write down some steps of construction. Consider a quadrilateral A, B, C, D with diagonals AC and BD. Let G and H be the midpoint of BD and AC respectively. Then join H and G to the midpoints of sides E and F of sides AB and CD respectively. So here is our whole construction of diagram which is written here. Now come to the question again. We have to prove that this diagram, this inside diagram EFGH forms a parallelogram. This is our real question which we have to prove. So it means we have to prove that the opposite sides are equal and parallel. That means EG is parallel to GF, EH is parallel to GF and EG is parallel to HF. So let's start. First of all, we will write down the position vectors of all these points. Position vectors of E, F, G and H are OE is since E is the midpoint of this side, so its position vector is the midpoint of A and B divided by 2. Next is F and OF is C plus D divided by 2. Next is G and G is the midpoint of this diagonal. So for G the position vector will be B plus D divided by 2. And for H A plus C divided by 2. Now EG and HF will be find out. EG is equal to OG minus OE, and OG is B plus D divided by 2 minus A plus B divided by 2. So the answer is D minus A divided by 2. Similarly, HF is OF minus OH, and OF is C plus D divided by 2, and OH is A plus C divided by 2. So the answer is D minus A divided by 2. Both of them are equal. Now come to next two sides. FG and HE. FG is OG minus OF, and HE is OE minus OH. By putting values and simplification, the answer will be B minus C divided by 2, which is equal for both sides. Hence, we can write EG is equal to HF, which means EG is parallel to HF, and FG is equal to HE, and FG is parallel to HE. Hence, EFGH forms a parallelogram. So here question number 12 is completed. In question number 13, we are given with proof that the line segment joining the points of the diagonals of a trapezium is parallel to the parallel sides, and its length is half of the difference of the lengths of the parallel sides. So in mathematical form, we have to prove two things here. First of all, EF. Let us explain the diagram first. For example, the diagram ABCD is a trapezium, and F is the midpoint of BD diagonal, and E is the midpoint of AC diagonal, and we are here join the point E and F. So the line segment EF is parallel to this line segment and this line segment, that is AB and CD. And the second to prove is EF is the half of the difference of these two sides, means AB minus CD, and it's half. And we have to prove these two things here. So first of all, consider this small part of the diagram, which is like this. Here is point E, G, D, A, and C. So I have drawn this part. Okay, so now the angles, these two angles will be equal because of the alternate angles. So now we solve this diagram first. Consider triangle CED correspondence with AEG, and here angle CED is equal to angle AEG. The reason is vertically opposite angles. and side CE is equal to AE because we are given that E is the midpoint of this diagonal. It means CE must be equal to EA. So C is the midpoint of, sorry, C not E. E is the midpoint of AC. Then the last thing is that these two angles. So angle DCE is equal to angle GAE. The reason is alternate angles. Hence, triangle CED is congruent to triangle AEG. Hence, we can write the corresponding sides and corresponding angles. So the side DE is equal to EG because the corresponding sides of congruent triangles, and AG is equal to CD. So mark this as equation number 1 and this as equation number 2. So now here consider this triangle. I have drawn this separately. So let us draw this triangle. This is like this triangle. So the name of its vertices are B, D, G, E and F. So since E is the midpoint of DGY from equation number 1. Equation 1 shows that this is the midpoint of this whole line segment. Also, F is the midpoint of BD. Why? Because this is already given in our question. So if these 2 points are the midpoints of two sides of triangle, then the line segment joining the midpoints is parallel to this line segment and half of this line segment. This is a well-known theorem for triangle, for any type of triangle. So we can write here EF is parallel to GB and EF is half of the length of GB. Hence we can write it as EF is parallel to GB is a part of AB. So if EF is parallel to GB, then EF is parallel to AG also, or AB also. So we can write here EF is parallel to AB and CD because GB is a part of AB. So first is proved, and the second is EF is 1 by 2. Then we replace the value of GB. So if we look at the diagram, GB is equal to AB minus AG. So AB minus AG. And from equation number 2 we have AG is equal to CD. So EF is equal to AB minus CD from equation number 2. So here second part is proved. I hope you have no confusion in this whole solution. If you have any confusion, you can ask me in comment section. And how did you like my video? Please tell me in my comment section. Here we have to complete our lecture. In next lecture, we will start question number 14, 15 and 16. Until then, you keep yourself happy and healthy. Take very good care of yourself. Remember me in your prayers and Allah Hafiz.